This is problem 47 from page 270 or thereabouts. 47's on 271. A 13,500 Newton car, is that its mass or its weight?
That is weight.
That's its weight, yeah. That's it, the weight of the car, right? Okay. How do we know that's the weight and not the mass? Guys, you'll have plenty of time to chat, I promise you. How do we know it's the weight and not the mass? Is it the units?
Yeah.
There we go, it's the units. Yeah, if it's kilograms, it's mass. If it's newtons, it's weight. Traveling at 50 kilometers per hour rounds a curve. So 50 kilometers per hour. Another thing that's evil, right? Rounds a curve of radius 2.00 times 10 to the 2. Why didn't they just write 200? Yeah, they're all scientific or something like that. Maybe they're doing like sig figs, which is a way to say that we know 3 digits, right? Although the 50 does, yeah, it's 50.0, right? So they're trying to say that we have 3 digits here. They're being very strict about that. Okay. So what do we do with kilometers per hour? Do we divide by 3.6 to get meters per second? Is that our first thing? Yeah. So kilometers per hour are evil. 50 divided by 3.6. That comes out even to 13.8 repeating. Yeah. Do you remember that? The conversion factor from kilometers per hour? Yeah? No? That's what it is, right? And then I think don't we need to know the mass of this thing? I feel like we do. So I'm going to go 13,500 divided by 9.8 to get the mass. And then I recognize this. So 13,500 divided by 9.8. Yeah. So there's the mass. Here's the velocity in meters per second, right? Now I'm ready to play. I don't even know. I have no idea, by the way, whether it asks about anything like this. It says, calculate the centripetal acceleration of the car. Okay, I can do that. I'm going to do v squared over r, right? So 13.8 repeating squared divided by 200. So 50 squared divided by 200 equals 0.96545 or something like that. That's not very much. That's not very much acceleration. The force that maintains the centripetal acceleration, well, isn't that F equals ma?
Yeah.
Right. So once you have the acceleration, just multiply by the mass. That's this thing, right? So 1377.55 kilograms times 0.9645. So I'm going to store that guy just for fun. And I'm going to go times. And I get that the force is 1328.65 newtons. Are these the right answers? Are we getting them right so far? I'm hoping. The minimum coefficient of static friction between the tires and the road that will allow the car to round the curve safely. Do we just say force of friction is mu times m times g? Yeah, and we need this much friction force, right? So 1328.65 newtons is mu times, isn't m times g that? Yeah, I mean, I could take this and go this times 9.8 and get this again, but I'm way too lazy to do that, so I'm just going to go 13,500, right? So this divided by 13,500, and I'm getting that it's 0.098, something like that, yeah? 0.0984. Is that the right answer? Yeah? Yeah, it doesn't need much because it's really not going very fast and it's a very big corner. Are we good? So yeah, mu mg, centripetal accelerations v squared over r, F equals ma. You can also make formulas like mv squared over r, or m 4 pi squared, right? Centripetal force is like that. So I would, I mean, later today, if you've got time, I would, here under test prep, I would make your cheat sheet, sit down and with somebody and write it all down. I put the examples of how to do all the orbit problems, how to type them into your calculator on the whiteboard. I don't know if you were there, I don't know if you copied it down, but if you're having trouble with that, I put it in your cheat sheet, right? And then make a list of these things, and then next time you'll have the mock test and you can revise your cheat sheet, maybe write on the back side of it, right? All the things that you need. Yeah.
Are you gonna make videos?
Oh yeah.
Sounds great.